All right, hey guys, we're going to next talk about how to solve radical equations. So building off of all of the previous rules that we've talked about using radicals, we're going to talk about now how we can apply them to solve radical equations. All right, so pretty basic to start off. We define that a radical equation is just an equation that has a variable somewhere in a radical symbol. Right, so here are a couple quick examples. Now, essentially, the process for solving one of these things is that we first want to basically just rewrite the equation so that you have a radical by itself on one side, right? And then what you're going to do is you're going to get rid of that radical by raising both sides to the power that would get rid of whatever kind of radical you have. So if you have a square root, you'd want to square both sides. If you have a cube root, you want to cube both sides, and so on and so forth. And then step 3 says to combine like terms, but essentially what you're doing there is you're going to simplify it as much as you can. If you still have something that has a radical in it, you're just going to repeat these first 3 steps until you don't anymore. And then whatever you end up with something without any radicals, you then solve that. But now this last step is very important, and we'll see this in a couple of examples that we'll do. But you need to check all solutions for what are called extraneous solutions. Now, basically what an extraneous solution is, or how does it come up in this context, is that essentially you'll get some number that if you plug back in, so if you evaluate in the original expression, and this leads to some kind of indeterminate form or some kind of undefinedness, right? So if you evaluate in the original expression, it would lead to something being undefined or not true. All right, so we'll see that come up in just a moment here, but let's go through some quick examples. Now, in this first example here, we have square root of x is equal to 8. Now, in this case, your radical is already by itself, so that's fine. So our first step here, let me just rewrite this. Our first step here is, since we have a square root, we're going to square both sides. All right, so if we square both sides, on the left side we get an x, on the right side we get a 64. All right, now this one's a pretty basic example, so you can see that x is equals 64 is going to work, because if you check it into the original, you get square root of 64, which is 8. So then that does work. So this is a true solution here. All right, so that's not too exciting, but that sort of lays the groundwork for what we need to do here. All right, so now let's look at this example here. So now we have square root of x minus 6 minus 3 is equal to 0, right? So of course, the first thing we want to do, now this is where it's a little bit different. Now we need to make it so that our square root of x minus 6 is by itself on one side. And of course, to do that, we would need to add this 3 to both sides. So then that way we get square root of x minus 6 is equal to 3. All right, so of course now I want to square both sides of this, and let's maybe do it this way. All right, so our second step, I'm going to indicate here in orange, is again, we want to square both sides of our equation here. Now, of course, when we do that, on the left side, the square root and the square undo each other, and we get x minus 6. And on the right side, we get 3 squared, which is 9. All right, so now we just solve this equation. I guess this is technically the next step. Right, and I guess really that would also, I guess, be in here. And now what we're technically doing is just solving this equation, right? So we would add 6 to both sides, and we would get that x is equal to 15. All right, I think I have my steps maybe mixed up here. Yeah, so this would be, I guess, technically step 5, right? Step 4 was if there are still radicals, repeat, but there are none, so we just go right to solving. And we get x is equal to 15. And of course, if we check this, we get square root of 15 minus 6 minus 3. which is going to be equal to a square root of 9 minus 3, which is 3 minus 3, which is 0, right? So then that does show that this will work in solving this equation. All right, so that's another example. Again, hopefully not too bad. Now, of course, that doesn't really look like a 3, but that's what it's supposed to be. So this is a cube root of x plus 11, all right? So again, even though we have a cube root here, the idea is still the same. I want to get the radical by itself. So first, let's subtract 11, and we have a cube root of x is equal to negative 3. So of course, now we can cube both sides. And we'll get, if I cube this, we'll get just the x, which is what we want. And if we cube negative 3, well, that's negative 3 times negative 3 times negative 3. So that's negative 27. And of course, if we check, we get a cube root of negative 27 plus 11. And of course, a cube root of negative 27 is a negative 3. And if we add that to 11, we get 8, which of course is what we want. So again, that answer is good. All right, so far so good. Now, what happens if it gets a little bit more complicated, right? Because now we have x's on both sides. All right, so let's check it out. So again, here, our radical term is already by itself on the one side, so we don't have to move anything around. We can just go right to squaring both sides. So let's do that. All right, now on the left side, this is straightforward because the square root and the square undo each other, and we just get 5x plus 4, right? But on the right side, we really need to FOIL this, right? We need to do x minus 4 times x minus 4. So of course, if we FOIL that out, we'll get an x squared minus a 4x minus another 4x plus 16. So now if I simplify and put it over here, we're going to get x squared minus 8x plus 16. So now you have a quadratic, so you want to move everything to one side and then try and factor this, right? So let's take these terms from the left and we'll move them to the right. I'm just going to do this all in one shot. Right, so on the left side, everything cancels and I get a 0. Then on the right side, we have x squared minus a 13x, and then plus a 12. So of course, the trick here is let's try and factor this. So if we can factor it, I need two numbers that multiply to a positive 12, and that will add to a negative 13. So if we think about that, I suppose that negative 1 and negative 12 will do the trick, right? If we multiply them, we get positive 12. And if we add them, we get negative 13. All right, so now this tells us the x minus 1, if that were equal to 0, tells you x is equal to 1. Right, and then this one tells us, oops, I shouldn't do that. The second one tells us that x is equal to 12. All right, so now let's check both of these. So the last thing we need to do is check. And let's see. Now, if you have a square root of 5, if we assume that x is 1 here, 5 times 1 plus 4. This is the left side, so that will give you a square root of 9, which is equal to 3, of course. Now, this was the right-hand side. But if we look at the left-hand side, we get an x minus 4, so a 1 minus 4, and that's negative 3. So this is the first case where these two things are not equal. So then that means that x equals 1 is an extraneous solution. All right, so that means that we're going to throw it out. We're going to come up here and we're going to remove x equals 1 from our solution. right? So now we need to check. Get a little bit more space here. Okay, so x equals 12, we're now going to check. All right, so if we plug that in, we get a 5 times 12 plus 4. All right, so that will give us a square root of 64, which is 8. And if we check it in the right-hand side, we'll get a 12 minus 4, which is also 8. So these two match. So then that means that x equals 12 is still a solution. So in this case, x equals 12 will work here, right? So again, 1 did not work because when we plugged it into the original equation, we got something different on the right and left-hand sides. Right? Okay, so next example here, now we have a square root on both sides, right? Now this is a more sort of innocent version of what's going to happen here, because now on the left side, I have a square root by itself. So if I square that, that should help. And whatever I do to the left-hand side, I need to do to the right-hand side. Now what happens here is that the left side will just become 4x squared plus 5. And then on the right-hand side, we can say that this is 2 squared times our square root squared. Right, so of course, that's just going to give you a 4. And then this will just become x squared plus x minus 3. Let's bring down 4x squared plus 5. So now if we distribute on the right-hand side, we get a 4x squared plus 4x minus a 12. And again, we didn't do anything to the right-hand side. But now we have a quadratic, so let's try and move everything to one side. And then, of course, something nice happens, because once we move the 4x squared over, we no longer have a quadratic, so that would be a little easier to solve. So now we get 0 is equal to a 4x minus 17. So now if we just solve this, we add 17 over. And we get 17 is equal to 4x. So then x is 17 over 4. Right. So of course, at this point, of course, you would want to check this, but I'll leave it up to you to check that this is a solution. Just for time's sake of this video, I don't want to go through it, but you would want to check that this is a solution, and this one should work. All right, as long as both of these square roots are positive, then you're in good shape. Okay, but let's look at one where we have cube roots, and then we'll look at a slightly more messy one, and then that will wrap up our discussion on radical equations. Right, so here this is almost similar method as the last one. So here we need to cube both sides. Right, and just like before, the left side will be a 2 cubed times a cube root of x plus 5 cubed. And the right side is just a 23x minus 5. So of course, the left side we can write as 8 times x plus 5 is equal to 23x minus 5. So now when we distribute on the left side, we get an 8x plus 40 equals 23x minus 5. So let's move the 8 over, 8x to this side, and we'll add the 5 to the other side. So then on the left side, we have a 45. Right side, we get a 15x. So then divide both sides by 15, and we get x is equal to 3. Okay, so now we can check in the original equation right? And the left side will get a 2 times the cube root of 3 plus 5. So that's a 2 times cube root of 8. So that will give you a 4. And then on the right-hand side, we got a cube root of 23 times 3 minus 5. So we get a cube root of 64, which is also 4. So those are equal, so then the solution works. Okay, so again, hopefully not too terrible. So the last one that I want to do is now, what if you have to do this sort of thing twice, right? So everything we've only had to sort of square one time, and we've been lucky with that so far. Now in this example, again, the strategy remains the same. We want to get one of these square roots by itself. So the easy thing would be to add the 2x minus 1 to both sides. So then on the left side, we just have the 3x plus 1. And that's equal to 1 plus square root of 2x minus 1. So now we can square both sides to get rid of the square root on the left. And that's just going to give us a 3x plus 1 now. But on the right side, again, we're in a FOIL situation. We need to do 1 plus square root of 2x minus 1 times 1 plus square root of 2x minus 1. So now if we FOIL that, we'll get a 1. So 1 times 1 is 1, plus a square root of 2x minus 1, plus another square root of 2x minus 1. And then we get plus square root of 2x minus 1 squared, or just a 2x minus 1. So then on the right side, we can write this as 1 plus 2 square root of 2x minus 1 plus 2x minus 1. And all this is equal to 3x plus 1. So on the right side, I guess we can clean up a little bit. We can say that the 1's cancel. And then we have 2x plus 2 square root of 2x minus 1. And this is all equal to 3x plus 1. So now we can move this 2x over. And then we have x plus 1 is equal to a 2 square root of 2x minus 1. So now to get the root completely by itself, we could divide both sides by 2. So then we have that x plus 1 over 2 is equal to square root of 2x minus 1. So now we can square both sides, and then we won't have any radicals left. Right? So I'm actually going to write the left-hand side as a 1/2 squared times an x plus 1 squared. And then the right side will just become 2x minus 1. So now if you square a half, that's 1/4. And then if we FOIL out x plus 1 squared, that will become an x squared plus 2x plus 1. And then that equals 2x minus 1. Right? Now, just to get rid of this fraction, I'm going to multiply both sides by 4. So I can write this as x squared plus 2x plus 1 is equal to 8x minus 4. Right? So this was multiply both sides by 4. So now we have a quadratic, so let's move everything over. We'll add the 4. So on the left side, we finally get x squared minus 6x plus 5, which we can factor as what? So I need two numbers that multiply to 5, add to -6, so -5 minus 1 should do it. So that gives me x equals 5 and x equals 1. Right, but of course we need to check in the original to make sure that this works. And then we're done. Right, so the original Let me just rewrite it here so we have it. 3x plus 1 minus square root of 2x minus 1 equals 1. So first, let's check x equals 5. Right, so if we plug in a 5, we get a 3 times 5 plus 1 is a square root of 16 minus square root of 10 minus 1, so 9. Does that equal 1? Well, that will give us 4 minus 3, which does equal 1. So that works. Now, if we check our other x value, which was 1, then we'll get a square root. If x is 1, then we get a 3 times 1 plus 1 is a 4, minus a square root of a 2 times 1 minus 1, so that's a 1. Does that equal 1? And of course, we get 2 minus 1 equals 1. So that one also works. All right, so in this case, both of these solutions work. No extraneous this time. All right, so that is this video on solving radical equations, and I will see you next time.